about geometry for the senior intermediate class. But before we start, what is geometry? Geometry is basically the study of all figures in space. So here's what we're going to do today. We're going to start off with some lines and angles, and in that we're going to learn about vertical angles, parallel and perpendicular lines, and transversals and angles. Then we move on to triangles, and we're going to learn about the types of triangles, properties of triangles, the triangle inequality theorem, which is pretty fascinating, and the Pythagorean theorem. Then we go into quadrilaterals, and in that we're going to learn about properties of quadrilaterals and the different types of quadrilaterals we have. Then we move on to polygons. So we're going to learn about the different types of polygons we have and our basic property of polygons. And lastly, we have the circle. And we're going to learn about the basic properties of circles and the angles and chords in a circle. So now let's start off with our first topic, lines and angles. So let's do some definitions real quick. A line is a collection of points, of infinitely many points, extending infinitely in both directions. Sort of like this, but longer. And then there's an angle, which is a combination, I think I spelled that wrong, of two rays extending from a common point. So it looks like this. And the point is my head, or me, the body. Anyways, so there are multiple line relationships that we can look at. First, we have two intersecting lines, and they intersect at one point and one point only. Then we have parallel lines, which never intersect, kind of like the sides of a railroad track. And we show that they're parallel by these little arrows in the middle of the line. And then finally, we have collinear lines. It might be hard with the blue and the green, but if you can see it, there's a green dotted line above a blue solid line. And they're collinear, meaning they're exactly on top of each other, like a sandwich, but infinitely thin. So, not a good sandwich. And then we have vertical angles. So, when we're going to talk about our intersecting lines. If you have two intersecting lines, you know for sure that angle 1 right here is equal to, or congruent to, they're sort of the same thing, not really, to angle 2. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. These are called vertical angles. Another thing you might notice is that angle 1 plus the measure of angle 1 plus the measure of angle 3 is 180 degrees. And the measure of angle 2 plus the measure of angle 3 is also 180 degrees. And the measure of angle 2 and the measure of angle 4 is also 180. The measure of angle 1 and the measure of angle 4 is also 180. Whenever you have two angles that add up to 180 that are adjacent to another, they are called linear pairs or linear angles. That might be a bit too hard for you to see down there. So let's try an example. We have two intersecting lines, and this angle is x plus 16 and this is 4x minus 5. And we're supposed to solve for x. So here's how we're going to do it. We know that this angle and this angle are equal. So x plus 16 is equal to 4x minus 5. Bring x over here and 5 over here. You have 3x is equal to 21. Divide by 3 on both sides, and you have x is equal to 7. Now let's move on to parallel lines and transversals. So for this topic, we're going to focus on our parallel lines and an intersecting relationship. So here are three different types. We have parallel lines here, and then an intersecting line. So remember, line N and line L are parallel to one another, and N is our transversal in this case, as in it is the line that is going through some parallel lines. So from parallel lines, you get a lot of good relationships. And the first one is called corresponding angles. And it's a postulate, meaning it can't be proved, but you just know it's true. So from this, we get that angle 3 is congruent to angle 7, because if you look here, they correspond in their quarter. Like if you were thinking of a graph and you have quarter 1, 1, 2, 3, and 4, then you have another graph, quadrant 1, 2, and 3, and 4. The 1s would correspond, the 2s would correspond, the 3s would correspond, and the 4s would correspond. Same thing here. Our quadrants 1 and 5 are congruent, then 2 and 6, then 3 and 7, then 4 and 8. So that's our postulate. Then we can move on to some theorems. So we have alternate interior theorem, and this can be proved using the corresponding angle postulate, but we're not going to do that. So what we get from the alternate interior angles is that the alternate interior, so we're going to focus on 3, 4, 5, 6, are congruent. So angle 3 and 6 are congruent, and angle 4 and 5 are congruent. See? They're alternate one another. You can also develop a bunch of other relationships from these three main ones, but we're going to focus on these three. From there, you can do whatever you want. Then we have our alternate exterior, which is basically like alternate interior, but guess what? It's on the exterior. If you guys don't know what interior and exterior means inside, and exterior means outside. Interior, inside. Exterior, outside. That one really doesn't work, but it's the opposite of interior. So we have alternate exterior. And this focuses on 1, 2, 7, and 8. So 1 and 8 are alternating. So 1 and 8 are congruent to each other. And 2 and 7 are alternating. So those two are congruent. So what I'm trying to say is there's a lot of congruent angles. For example, angle 1 is congruent to angle 4. I'm just going to stand here. Angle 1 is congruent to angle 4 because of vertical angles. Angle 1 is congruent to angle 5 because of corresponding. Angle 1 is congruent to angle 8 from alternate exterior. Angle 4 is congruent to angle 5 from alternate interior. And angle 4 is congruent to angle 8 from corresponding, which is up here. And then angle 5 is congruent to angle 8 from, where is it? Vertical angles. And let's do the same thing for 2, 3, 6, and 7. Angle 2 is congruent to angle 3 through, where is it? Vertical angles. Angle 2 is congruent to angle 6 from corresponding. Angle 2 is congruent to angle 7 from alternate exterior. Angle 3 is congruent to angle 6 because of alternate interior. Angle 3 is congruent to angle 7 from corresponding. And angle 6 is congruent to angle 7 from vertical angles. Now we move on to our next topic, which are parallel and perpendicular lines. And in all my experience in geometry, and I'm taking geometry in school right now, I can say for certain that parallel and perpendicular lines are by far the most important line types there are. Everything, well, almost everything comes from parallel and perpendicular lines. So, like I said before, parallel lines are basically two lines that never meet. They don't share any points, and it's like the ends of a railroad track. Those tracks never meet. They run alongside of each other for all of infinity. And then we have perpendicular lines. And you see these everywhere. You also see parallel lines everywhere. You can see them where walls intersect. You can see them at the edge of your paper. You can see them at the edge of this screen you're watching this on. They're everywhere. And perpendicular lines are special. These are intersecting lines that form a 90-degree angle or a right angle. And you can see these everywhere in geometry, like squares and more squares and rectangles and more stuff like that. So, and more parallel lines. Two walls that are opposite each other are technically parallel. So the wall behind me and the wall in front of me, they're parallel to each other. They never meet because the walls aren't like this. They're like this. And this may not seem parallel, but it is. Now let's move on to triangles. And basically, triangles are what the name says, tri-angles. Tri means three, angles are angles. Three angles, three sides. Those are what triangles are. And let's start off with the types of triangles. So we classify triangles by two different criteria. We either classify them by side or by angle. So let's start with side. First, we have our scalene triangle. It's a really weird name. And basically that means that if you have a scalene triangle, none of the sides are equal. And a way to remember that is scalene is a really weird name. It's odd. It doesn't fit in. None of the sides of a triangle fit in with themselves. That's how you remember that. Then we have isosceles. And it's basically a triangle where two of the sides are equal. And you can remember that by isosceles sort of sounds like ice cream, and an ice cream cone, two sides are equal. I guess that's how I sometimes remember it, and you can use that too. And then it just becomes part of your brain. Then we have classifying them by angles. Our first one is an obtuse triangle. This means there's one giant angle. It's giant. And that giant angle measures more than 90 degrees. And because it measures more than 90 degrees, the other two angles, because there are three angles, measure less than 90, or they are acute. Then we have our acute triangle. And acute triangles are pretty cute because they're tiny. That's how I remember them. But basically, in an acute triangle, all of the angles, all three angles, measure less than 90 degrees. They're tiny, but cute. And then we have our right triangle. And basically, it has one right angle in a right triangle. And the rest are acute because 180 minus 90 is 90. You'll see why later. So from this, we can get one overall triangle, which is an equilateral triangle. And it's classified by both its sides and angles. In an equilateral triangle, it's all three lengths are the same and all three angles are the same. So it's like the perfect triangle. So now let's move on to properties of triangles. And to do this, let's break down the word triangle to tri and angle. And if you know, I don't know if it's Greek or Latin, then you know that tri means three. So that means triangle basically means three angle. So from this, we know that triangles have three sides and three angles. And in a triangle, something unique about it is that the angles of a triangle add up to 180 degrees, meaning that this angle plus this angle plus this angle is 180 degrees. And the perimeter of a triangle is basically the perimeter of any figure. It's the length that you have to walk around it, or in a triangle's case, the sum of its three sides. And finally, the area of a triangle is basically 1/2 base times height. So what parts are these in triangles? Let's say we have a right triangle. We know it's a right triangle because of that little square degree part. This bottom part right here is our base, and coming up from it is our height. And our longest side right here is called our hypotenuse. And let's say we don't have a right angle like this one. This one's obtuse. It's not to scale, but you'll see. So this bottom part here that's flat is called the base. And extending downward from the utmost point, or the point across from the base, is the height. And it's perpendicular to the base. Remember, perpendicular means that those two lines or line segments they intersect and form four right angles. And these two right here are lines. So let's try an example. We have a triangle right here, and we're given that this is A, B, C, or triangle ABC. And we're given that the degree measures are x, 2x, and 3x plus 30. And we need to solve for x. So here's how we're going to do it. We know that x, 2x, and 3x plus 30 add up to 180. So let's write that. Then we add up x plus 2x plus 3x, which is 6x, which gives us 6x plus 30 equals 180. Subtract 30 from both sides, we get 6x equals 150. And then divide 6 from both sides, you have 150 divided by 6 is 25. Therefore, x is 25. So let's try another example. We have this right triangle here. It's a 3, 4, 5 one. And we want to find the area and perimeter. Well, area is easy. 1/2 base times height. 1/2 times the base and the height, which is 1/2 times 4 times 3. 4 times 3 is 12, half of that is 6. 6 units squared. And for our perimeter, we're just adding 3, 4, and 5. So side 1 plus side 2 plus side 3, or 3, 4, and 5, add up to 12 units. Now let's move on to the triangle inequality theorem. And basically what the triangle inequality theorem says is that two sides of any triangle when they're added up, their sum has to be greater than the length of the third side. For example, I have a giant triangle drawn here with sides A, B, and C. And in this, we have to actually be a triangle. These three conditions must be met. A plus B has to be greater than C. A plus C has to be greater than B. And B plus C has to be greater than A. Now you might be wondering, why is that? Well, here's an example. Let's say A plus B is equal to C. So I have a piece of paper here. Let's say this side right here, this top part is A, this base is C, and this other leg is B. Now the sum of these is directly equal to C. The sum of A and B is equal to C. Now watch as I try to connect these two and keep C straight. They don't meet. They sort of meet, but they converge at that line. Their meeting point is basically the base, meaning we can't have that because no triangle there, just a line. Now let's say I have A plus B is less than C. Here we have A, B, and our base C. Watch what happens when I try to connect them. So I'm doing it, I fold it, and there's a giant gap in the middle. They don't meet at all. And lastly, we have our normal conditions. We have A, B, and C, which is this middle section. Watch what happens when I try to connect the ends of A and B. They make a triangle. Ta-da! Meaning the sums of A and B have to be greater than C, or else you're going to have a sad line. Our last part of triangles, unfortunately, is the Pythagorean theorem, or as I call it, Pythag. Basically what it says is if you have a right triangle, remember, this only works for right triangles. Right triangles. Triangles with 90 degrees. The thing that has a tiny weird box in the corner. Right triangles only. You can use A squared plus B squared. Remember, A and B are legs, is equal to C squared. C is the hypotenuse, or the longest thing. And remember, the longest leg the longest side, or the side opposite the 90-degree angle, that is your hypotenuse. Remember, call it the hypotenuse. Don't call it anything else. You're just going to confuse it somewhat. Anyways, you have A squared plus B squared equals C squared. Or if you take the square root of both sides, the square root of A squared plus B squared is equal to C. Remember, it's really important, super simple, works for many problems. So from the Pythag, you can get these Pythagorean triples, which are basically numbers that satisfy A squared plus B squared equals C squared. And these are really useful. Like, if I were to have a right triangle with legs 3 and 4, I can easily think, oh wait, it's a 5, the hypotenuse is 5, without having to square 3 and square 4, add them, and then take the square root of that. That's just annoying. So, here are some examples of Pythagorean triples, and there are infinitely many. So we have our base ones, 3, 4, 5, 5, 12, 13, 20, 21, 29, 8, 15, 17. Remember, these are only some of the infinitely many base ones. And, all of the numbers in orange are hypotenuses. And I didn't color code 3 and 4 or any of the black ones because they're interchangeable. Because commutative property. Anyways, from these Pythagorean triples, you can basically multiply all three of sides by the same number or ratio to get a new Pythagorean triple. For example, for 3, 4, 5, you can have 6, 8, 10, 9, 12, 15, 12, 16, 20, and 15, 20, 25, and so on. So if you notice like 15 and 20, you can be like, the last one's 25. So we also have 10, 24, 26, 15, 36, 39, 20, 48, 52, 25, 60, 65, 40, 42, 58, 60, 63, 87, 80, 84, 116, 100, 105, 145, 16, 30, 34, 24, 45, 51, 32, 60, 68, 40, 75, 85. Now I mean like, that's a lot of numbers. I'm not going to memorize that. You don't have to. Just memorize these 4 main base ones, and these are the ones that appear in most problems. So you just need to remember 3, 4, 5, 5, 12, 13, 20, 21, 29, 8, 15, 17. Because from there, you can get any of the others. Now let's move on to quadrilaterals. And like triangles, quadrilaterals also has a little word hidden inside of it, which shows what it means. And that part is quad. Quad means 4. So because of that, in a quadrilateral, there are 4 angles and 4 sides. Something unique about a quadrilateral is that its angles add up to 360 degrees. And here's why. Let's say I have a quadrilateral here, and we draw one diagonal. Remember, a diagonal is when you draw a line from one vertex to another vertex that it isn't adjacent to. Otherwise, it'll just be a side. For example, this to here is a diagonal, this to here is a diagonal, but this to here isn't, and this to here isn't, like this. Those aren't. So I got a diagonal, and you notice something. You make a triangle. Well, 2 triangles. There's one triangle here, and one triangle here. And they're marked with red or orange angles. So let's start with our orange angled triangle. In that, its 3 angles are marked with orange. And they might be equal or they might not be equal. But let's just say they're not equal. Because it's a triangle's normal property, they add up to 180 degrees. The same goes for this triangle. They add up to 180 degrees. And since these 2 together form this one, and these 2 together form this one, and this one, and this one, which is basically all 6 angles, you add up the 180s that they give you, and you get 360, which is why quadrilaterals angles add up to 360 degrees. Now let's move on to types of quadrilaterals. And let's start with a very simple one, a trapezoid. So a trapezoid looks like that. And a normal trapezoid just has one pair of parallel sides. That's literally all that's special about it. It's not really special. But let's say I do this. By the way, these arrows mean that they're parallel, and these ticks mean that they're congruent. But let's say I make these 2 congruent. From then, we have an isosceles trapezoid. That means we have one set of parallel sides, our bases, one set of congruent sides, which are these 2, 2 sets of congruent angles, meaning this and this are congruent, and these 2 bottom ones are congruent. Then our diagonals are congruent. So that means this. I don't want to draw on top of the words. That was a really bad diagonal. And this. These 2 diagonals are congruent. And then we have 2 pairs of supplementary angles, which are these 2 and these 2. You might not remember what complementary or supplementary means, so here's a bit of a quick review. Supplementary angles, meaning if 2 angles are supplementary, they add up to 180 degrees. And complementary, if 2 angles are complementary, they add up to 90 degrees. I usually get confused between the two until I learned a little trick, which is it is right to compliment someone. It is right to compliment someone. Right compliment. Right angles, remember, 90 degrees. So it is right to compliment someone. Compliment 90 degrees. Now let's move on to another type of quadrilaterals, or parallelograms. Now these are pretty vague. They're basically any type of quadrilateral that has opposite sides parallel to each other. So in a parallelogram, there are many interesting characteristics. We first start off with opposite sides are parallel. And that's sort of obvious because the name of the quadrilateral itself is parallelogram. Parallelogram. And opposite sides are congruent. So these two sides are parallel and congruent, and these two sides are parallel and congruent. And from that, we also have that opposite angles are congruent. So that means this angle and this angle are equal, and this angle and this angle are equal. And remember, they add up to 360, so that means these two angles have to are supplementary, or they have to add up to 180 degrees. And finally, the diagonals of a parallelogram bisect each other. So here's an example. We have a parallelogram here, not drawn to scale, and we have our two diagonals, which are in blue. So when we have our first diagonal, it is basically cut in half or bisected by this diagonal, meaning this right here is equal to this. And the same goes for this diagonal. This diagonal is bisected by this diagonal, so this is equal to this. Now let's move on to the kite. And this is a picture of a kite. It also looks like a kite you fly because it's called a kite. Anyways, in a kite, the diagonals are perpendicular. That means they form 4 right angles. And the long diagonal bisects the short one. So you see this is a long diagonal, and this short diagonal is bisected. As you can see, you might think that the long diagonal also gets bisected, but picture shows that's not going to be bisected. And there are 2 pairs of congruent sides. Our congruent sides are these 2 and these 2. Now let's move on to the rectangle. And basically, a rectangle is like a step down or a more specific parallelogram. So it has every single property of a parallelogram and more. And that tiny bit of more is that its diagonals are congruent and that it forms 4 90-degree angles. So let's go through it. So here we have a rectangle. These 2 opposite sides are both congruent and parallel. There should be another arrow here, but I forgot. These 2 opposite sides are congruent and parallel. And then we have 4 90-degree angles, and technically these are all supplements. And then we draw our diagonals, and we see that our diagonals are equal. So that means when we bisect our diagonals, these 2 are equal to these 2, and this is equal to this, and this is equal to this, and this long thing is equal to that long thing. So that's a rectangle. Before we continue to our last 2 quadrilaterals, let's have a bit of a review. Now, you may notice that I use a lot of different markings. So here's a basic rundown of all of them. First, we have those double bars, and they're used when we're saying 2 line segments are parallel. For example, I can say segment AB, double bar, is segment AB, double bar, B, CD. That means segment AB is parallel to CD. I think that's what I said. And if you have 2 lines and you want to show 2 segments are parallel in a diagram, you would use pairs of arrows. You either use 1 or 2 or more than that if you need to. Then we move on to perpendicular. If I want to say that segment AB is parallel to CD in a sentence, I would say AB, this weird upside down T, CD, which means AB is perpendicular to CD. Or if I want to show that in a diagram, I would do that little upside down L thing. Perpendicular symbols are basically upside down stuff. And then we have congruent lines. Those are just represented by 1, 2, 3, or more tick marks. And the sides you want to show that are congruent, you indicate with the same tick mark. So if I were saying AB and CD are congruent, then I would put 1 tick mark. But if AB and CD are not, I would do 1 and 2 tick marks. And then we have congruent angles, which are basically the same concept as congruent lines, except they're curves. And then finally we have angles. I write my angles sometimes like this, or sometimes normally without this weird curve, because sometimes my angles look like L's and it's hard to differentiate them. Now, let's move on to our last two, which is the rhombus and the square. So let's start off with the rhombus. The rhombus is basically everything a kite has, except that its both diagonals bisect each other, and all of its sides are congruent. So basically, these two sides are parallel as well. These two sides are parallel. And then you have that this diagonal is equal to this diagonal. This part of the diagonal is congruent to this part, and this part is equal to this part, and all sides are equal. These two are, I said that already, these two are parallel, these two are parallel, these two are equal, these two are congruent, and these two add up to 180 degrees. Also, the diagonals still form a right angle. And then we have the square, which is basically everything we just went over, except for the trapezoid, combined and mushed into this. So in a square, it's basically everything like a rhombus and a rectangle, and it's the most specific you can get with quadrilaterals. So its diagonals are congruent to each other. They also bisect each other. So this is equal to this, which is equal to this, and which is also equal to that. And they still form a right angle. And then all sides are congruent. These two are parallel, these two are parallel, and all of these angles are 90 degrees. It's formula time. So let's go over all the area and perimeter formulas for the quadrilaterals we just covered. So we start off with the trapezoid. And in the trapezoid, we have base 1, base 2, which are basically the parallel sides, or the flat parts. And it doesn't really matter which one you call base 1 or base 2, but as I like to do it, I like to start from the ground up, like a building, where you start from the first floor and you build up. And then we have our height, which is basically when you take one of those points that connect the leg and the top base, and you draw a perpendicular line or an altitude down to the second base. That right there, that altitude is your height. So to find the area of a trapezoid, all you're going to do is base 1 plus base 2. So the sum of the bases, divide that by 2 and multiply that by h. It looks like this. Base 1 plus base 2 over 2 times height. And basically a perimeter is the sum of all the sides. Quick review. Area is how much is in the figure, and perimeter is how long would it be if you walk around it. Let's say you're at a park and want to find the area. You see how much park is in the park, and if you want to see the perimeter, you would walk around the park and see how long you walk. Then we move to our parallelogram. And a parallelogram has two parts, base and height. Base is basically, it can be either one of the parallel sides, but usually we do the one that's on the bottom. And so from that, you take one of the top points of the thing opposite, the side opposite of your base, and you drop an altitude. That's a right angle right there. And that's your height, or altitude. So to find the area of a parallelogram, you're going to multiply base times height. To find the perimeter, just do the sum of all sides. Or you can add up these sides, and you can add up this side and multiply by 2, just like a rectangle. So now, let's move on to a kite or rhombus. A kite or rhombus, they both have the same formula. All you have to do is multiply the diagonals, divide by 2. So this is D1, this is D2. You can switch them because it really doesn't matter. And you divide by 2. Remember that dividing by 2, I always forget. And so the perimeter is just the sum of all sides. But if it's a rhombus, it's 4 times one side because they're all equal. Now let's move on to our rectangle. A rectangle has 2 parts, length and width. It really doesn't matter which one you assign to, because either one works because of multiplication and addition. Remember, commutative property of addition and multiplication. So the area is basically the length times width, and you might be wondering why. Well, I like to think of it this way. Area is also basically the number of unit squares you can fit in. So if you think of a graph and you see how many squares you have along one side, how many squares you have on the bottom, just multiply them. Length and width. And in perimeter, basically add up length and width and multiply by 2 because this is also length and this is also width. They're equal. And lastly, we have our square, which is by far the most simple. For area, you take your side length, there's only one side length, so no confusion there, and you square it. And then for perimeter, just multiply that by 4. So there you have it, formula time. Now let's move on to types, well, polygons. And in that, let's start off with types of polygons. So there are like infinitely many polygons. And you also might be wondering, what is a polygon? Well, let's take a look at the word. We have poly and gon. Gon is just gon. And poly means many. Many gon, meaning many-sided. And polygons have at least 3 sides. So we have a triangle, 3-sided figure. Quadrilateral, 4-sided figure. Pentagon, 5-sided figures. And after you see they all end a gon, a gon, a gon, a gon. Yay. Hexagon, 6-sided figure. Heptagon, 7-sided figure. That's a 7-mile, by the way. I write my something weirdly. Octagon, 8-sided figure. Nonagon, 9-sided figure. Decagon, 10-sided figure. It will be helpful to memorize all 7, 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. It would be helpful to memorize all 8 of these. So then we have convex and concave, which is another classification. Convex basically means that if you draw the diagonals for this, they all end up inside. So diagonal, 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 and diagonal. Let's see. And those are all our diagonals. I might have missed one. No, I didn't. So basically, there you go. All of the diagonals are inside. However, a concave, if I try to draw a diagonal, so let's draw one here, draw one there. That one's good. Which one is it? Then this one I gotta do that. And that. So now I gotta do that. Oh wait, I already do that. Anyways, it becomes a confused mess. But in a concave polygon, if you try to draw diagonals, they will end up outside the actual figure, not inside. Inside. An easy way to remember this is concave. Caves are outside your home, I guess. They're outside of your normal place. They're far away. They're irregular. They're weird. And then convex, just, I don't know. And then we have regular and irregular. In a regular polygon, all angles are equal and all sides are equal. That's why it's called regular. An example of a regular polygon is a square or an equilateral triangle. There are no special names for regular pentagons, hexagons, and so on. We just call them a regular octagon, a regular hexagon. And then irregular, it basically means not regular. Now let's move on to properties of polygons. So let's start off with the sum of angles. The sum of angles has a specific formula, which is n minus 2 times 180. Whenever we're talking about polygons and you're wondering what n means, it means the number of sides or the number of vertices. Anyways, they're the same. So it's n minus 2 times 180. Now you might be wondering, why is that? So I'll show you why. So let's say we have a hexagon right here. Let's pick any point, and I chose this point. We're going to draw a diagonal. We're going to draw all the diagonals we can from that point. When we do it, we form 1, 2, 3, 4 triangles. And like we did with the quadrilateral, each of these angles, their little triangles, each of their angles add to 180 degrees. So 4 triangles times 180. Same thing with an octagon. I chose this point. We have 1, 2, 3, 4, 5. 5 diagonals from that point, or 6. 1, 2, 3, 4, 5, 6 triangles. And each of those 6 triangles have 180 degrees in them, so you do 6 times 180. Now you might be wondering, where did the negative and minus 2 come? Well, here's why. When you take a point and try to draw a diagonal, you're basically forming a triangle with every point you have that you draw it to, except for these 2 points. So n minus 2. For example, in this octagon, 8 sides, 6 triangles. In this hexagon, 6 sides, 4 triangles. You notice a pattern. N minus 2 times 180. Now let's move on to the number of diagonals. It's more of a counting one, but we're still going to go over it. It's basically n times n minus 3 over 2. And here's why. So let's use our octagon again. From each of these n points, or 8 points, because it's an octagon, we can draw a diagonal to each point except this one, and this one, because one of them is itself and the other 2 are already connected to it. So that's 3 points each point does not connect to, meaning n minus 3. And so that's for each of those n points, which is n. But in a diagonal, it connects 2 different points, meaning you overcount each of them twice. So you divide by 2. Now let's move on to our last topic of today, circles. And you might be wondering what a circle is. Well, a circle is a collection of all the points that are a given distance, or which is the radius, from a center point. For example, if you look at a light, most lights are circles. If you look at the sun, it's a circle. At least it looks like it. It's actually a sphere, but from our sight, it's a circle. Most cameras, the lenses, are circles. So that's a circle. And the area of a circle is pi r squared. And most people know a lot of digits of pi. I only know 3.141592653, I think. Anyways, pi is like infinite. You can find any digits you want in that order in it. For example, I can find my birthday in it. You can find your dog's birthday or any kind of number. It is highly likely, or it is gonna be in pi, because pi is infinite. And then the circumference is 2 pi r. I sometimes confuse them, so here's how I remember it. Circumference is the perimeter of a circle, meaning it's gonna be 1 dimension. So for this, it's just 1 arm. And then for area, it's gonna be 2 dimensions. It's gonna be length and width, because that's normal 2-dimensional things. So it's gonna be pi r squared. That squared represents the second dimension. Because when you write units for something, if you're doing perimeter or circumference, it's just units or inches or centimeters. But if you have area, it's gonna be inches squared, centimeters squared, units squared, radius squared. And a circle is made up of 360 degrees. Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!